Welcome to my presentation on Baltic Sea coastal water restoration. My name is Gerard Czarnewski. I'm head of the Coastal and Marine Management Group at the Leibniz Institute for Baltic Sea Research in Warnemünde, Germany. At the same time, I'm professor at Klaipėda University. What is it about? You will get an overview about the Oder Lagoon, especially the eutrophication problems, how to combat eutrophication, what are the suitable measures, and then we focus on mussel farming. Is it cost effective? Are there alternative possibilities on a small scale? And I will finish with summary and conclusions. The Oder area is located between Germany and Poland. And a speciality is that a relatively small coastal zone is facing a large river basin. 120,000 square kilometers of river basin with a lot of industries, with intensive agriculture and intensively populated. And this means a lot of nutrient emissions, nitrogen, phosphorus. And these are drained with the Oder River and entering the Oder Lagoon. This is how it looks like. So the area is scenic, is attractive, is under nature protection. But in summer, we have serious blue-green algae blooms and a high primary production in general. This means that the nutrient loads, nitrogen, phosphorus, cause eutrophication. And low water transparency is not the only problem. Another problem is, sometimes at least, hypoxia, oxygen-free water layers above the sediment. They cause fish kills, and they can, if they last over days, even kill mussels, which later pop out of the sediment. So what is the situation in the area? So the red bar shows the loads of phosphorus on the top and nitrogen on the bottom that would be acceptable to maintain a good environmental status in the Oder River. The situation 2010-2017 are the gray bars beside. And what you see is the loads have to be reduced by approximately 1/4. So we need additional load reductions. But this is potentially possible. But what we learned is that even if we reduce the loads, this would not cause a good ecological status in the Oder Lagoon, in the coastal waters. And another aspect is that the Polish agriculture is intensified. So there is a strong tendency to have even higher loads in future. And we have another problem in the lagoon itself. On the left-hand side, you see the Oder River plume in the lagoon as it is seen from the satellite. On the right-hand side, the phosphorus concentrations in the water. Where the Oder enters in the south, dark colors indicate in high concentrations. And then algae take up phosphorus and the colors become brighter, the concentrations lower towards north and west. But sometimes in summer, we see an opposite picture. In the west, we have red colors, extremely high phosphorus concentrations suddenly. Much higher than the loads or the concentrations resulting from Oder loads. What happens is that we have hypoxia, oxygen-free layers above the sediment, which cause a release of phosphorus to the lagoon. This is called internal eutrophication. And within a few weeks, approximately 400 tons of phosphorus can be released from the sediments into the water body. And this is approximately the load of 3 months of the Oder River. So a serious amount. So the starting point. What when river basin management fails? If river basin nutrient load reductions are insufficient? If a good water quality in the river does not cause a good status in the lagoon? If coastal waters are naturally eutrophied? Or if we have internal eutrophication as a special problem? But at the same time, if measures in these coastal waters are needed, are required by law, by the Water Framework Directive. The picture on the right-hand side summarizes the situation. We have on one hand side measures in the river basin, and they should preferably taken. So we should reduce the emissions of nutrients from agriculture, for example. If this is not sufficient, we should focus on measures in the river, retention measures, removal measures. But it might be that we need internal measures in the coastal waters, in the lagoon, to remove nutrients and support a good ecological status. How can this look like? What kind of measures are suitable? There are mechanical measures, groin rows, for example, to support sedimentation, to reduce the resuspension and increase water transparency. We can dredge, take out the sediment, dump it on land to remove nutrients. We can carry out a sediment capping, so to add clay over the sediments to avoid nutrient exchange. Or we can have a look at chemical measures, the precipitation of nutrients, especially phosphorus, and a permanent fixation in the sediments. These measures are costly, and in a lagoon with nearly 700 square kilometers, not realistic. But there are biological measures as well. Biomanipulation, selective fisheries so that we support planktivorous fishes who prey on algae and reduce eutrophication, macroalgae cultivation, floating islands is a fashionable aspect, enlargement and management of macrophyte areas which trap nutrients and sediments, the enlargement of natural mussel beds. But all these measures are not really realistic. The most promising one is mussel farming. And this is what we focus on. In the lagoon, in the Oder Lagoon, we have a special situation. We have low salinity. And waters with low salinities do not allow a common blue mussel farming. We have to take in different species. Zebra mussels, Dreissena polymorpha. Much smaller. And the question is, can we transfer the blue mussel farming approaches to Dreissena as well? Is mussel farming environmental friendly? Is it sustainable? What with respect to its efficiency, with respect to water quality improvement? Is it cost effective compared to measures in the river basin? And can it even be profitable? So this is the basic concept. On the left-hand side, you see the nutrient loads entering, for example, with the Oder River. They cause intensive production, algae growth. And the mussels are suspended in the water in farms, are filtering the water, are removing the algae, are removing the nutrients and fix them in their body. At the same time, they increase the water transparency. And as soon as we harvest the mussels, we remove the nutrients, and the mussels can be processed and used for different purposes. Human and pet food, but also mussel meal. They are very rich in proteins. And mussel meal can replace fish meal, and there's extremely high demand for fish meal, especially for aquaculture. And the shells can be used, for example, as organic fertilizer. This is the situation in the Oder Lagoon with respect to zebra mussels. They are living there for centuries, have a high total biomass of nearly 70,000 tons. And the limitation of their spreading is because of a lack of hard substrate and hypoxia, so that they once enter hypoxic areas, they would die. Ecologically, they are quite effective. The filtration rate of 1 square meter of mussel bed is 1 cubic meter water per day. Will be cleaned fully. The reproduction takes place usually in April, May, when the temperatures exceed 12 degrees. Eggs are left out in the water. Larvae are growing, and the larvae look for hard substrate and start to settle. Once they settled, they can, after 2 years, reach a size of about 12 to 14 millimeters and get a weight of about 1 gram. First experiments carried out by Sven Dahlke with Dreissena in the lagoon were very successful. They did grow much better than expected. But to use them for human consumption is questionable. They are too small, very likely, to be used in a similar way like blue mussels. How does the mussel approach looks like? So you have buoys on the top, floating on the sea surface. You have underneath a line, a carrier line, and below the carrier line, cultivation lines. On these cultivation lines, the mussels are growing. And these cultivation lines can be harvested. But to carry out this kind of approach, certain circumstances have to be met. We need certain preconditions. Sandy sediments. We need sufficient water exchange so that enough algae are drifted into the mussel farm. We need natural mussel beds in the surrounding so that natural larvae can attach to the collector lines. We need a low cultivation density because this allows us to avoid negative impacts on the sediments. And there should be, of course, no interference with other uses like fisheries and no risk of hypoxia, of oxygen-free zones, otherwise they would die. We carried out a lot of analysis, model simulations and calculations, and I will make a long story short. This shows the total costs of mussel farming and the total income you can get from selling different mussel products. And the figure shows how this develops with increasing cultivation area in the lagoon. You see that at the beginning, if the mussel farm is small, the costs are high, but the income is high as well. If we have very large farms, the curves move closer to each other. But the green line, the balance, shows that independently of the size of the mussel farm, it is always negative. So cultivation mussels, zebra mussels, means losing money. Even very large farms would lose about 20 cents per square meter of mussel farm. So a major challenge is to compensate these losses. So we need additional funding, subsidies. And this makes sense. So we could, for example, redirect agricultural subsidies. We could add a tax on fertilizer. Or we could develop a trading system for nutrient quotas. The idea behind is that we have a flow of money from the emitters, the river basin, to those who take out the nutrients from the environment, so that they get a compensation for their ecological service. So, let's briefly summarize the first part with respect to the Oder Lagoon. So, it is not more than a supportive measure to remove nutrients. Even extremely large mussel farms cannot remove more than 1,000 tons of, for example, nitrogen. This is only about 2% of the annual Oder load. In the lagoon, it's not profitable. It requires additional subsidies. And it's not cost-effective at the moment when we compare it to measures in the river basin. But as soon as we reduce the loads further, the costs of measures in the river basin become higher, and then they will become cost-effective. We can say that it's environmental friendly. We have as a benefit the production of fish meal as a mussel meal, as a replacement for fish meal. But what we cannot reach is that large mussel farms cause a regime shift, a shift from a plankton-dominated system towards a macrophyte-dominated clear water system. This is at least not possible in the lagoon. What are the alternatives if large farms don't work? So there's one scenario, a commercial farm for special purposes. For example, to produce feed for zoological gardens. There is a demand for zebra mussels. The second alternative is scenarios at the beach. And we can consider environmental farms. Let's start with a beach farm. Idea behind is to increase water transparency in bathing areas, because tourism is hampered by poor water transparency. So we establish a mussel farm around the beach. We calculated the costs and the efficiency, and the water transparency improvement is about 45 centimeters as a maximum. This is not too much. This would not cover the costs. So, not too promising. Alternative is to establish low-density mussel farms in areas where macrophytes formerly were present, in shallow areas, but where they were lost, but today could survive again. The mussels would filter the water, increase water transparency, and it is really possible to increase the available light by up to 45%. This means macrophytes could grow, and once macrophytes grow, they stabilize the sediment. They keep the water clean, and we could remove the mussel farm to a different place. Do the same exercise. Why is this important? This is important because macrophytes are a biological element within the Water Framework Directive. So they determine whether ecological good status is reached or not. So we need an improvement. So, a general summary. The strength Well, we can remove nutrients with mussel farms, increase water transparency, support the resettlement of macrophytes. We get high quality proteins and fat acids. We can use them to replace fish meal. We use native species, or at least a species which is present for a long time. We can possibly have a synergy with fisheries, create a benefit for aquaculture, may even support tourism. But there are weaknesses as well. It is an end-of-the-pipe solution. So the nutrients are passing all ecosystems, and at the end they are taken out. There are still uncertain effects on ecosystems. Mussels may, while filtering the water, take up pollutants and human pathogens, vibrions, for example. These floating devices can be subject to ice damage. We may have large losses due to predation. Ducks like mussels, and for them it's easy to reach them if they are floating. A minor problem, possibly the spreading and settling of mussels, so that if we increase the biomass, they can attach somewhere else in harbors and sport boats. But it's at the end not profitable. And we have in Germany at least an uncertain legal situation. We don't know whether we get permissions. It's a long process to get this permission. And we do not have a tradition in using mussel products and mussels itself. And the mussel meal production, which is in principle promising, requires large amounts of mussel. So this is problematic as well. So what can we conclude? Zebra mussel farming seems to be the most effective measure in freshwaters. It could support reaching a good ecological status in waters with limited external loads, not in large systems like the Oder Lagoon. And it can serve as a measure within the Water Framework Directive. But even if we want to run it by itself, with a financial compensation for nutrient removal, for improving water transparency, it could even be profitable. And with this, I'd like to thank you for your attention.